So we're just going to have a quick look at the EIGRP stub network types and the effects that they have in convergence in the EIGRP world. We've got three routers in the little network that we've got set up over here. We've got router 1, router 2 and router 3, all with a loopback address on each and also with just a network between them. So we've got a serial connection here and an Ethernet connection here. Now I've gone ahead and already set up those three routers with a basic kind of setup and also configured EIGRP on all of them in AS65001, just advertising the loopback address and also their WAN address, if you like, and also with no auto configured to disable automatic summarization. Okay, so we can see here on router 1 that we've got open on our terminals over here. If I do a show IP route, we can see here that it's got the 172.16.1, .2 and .3 networks. 1 is connected and 2 and 3 are via EIGRP. So we can see we've got connectivity all throughout our little network here. Now to configure stub networking, we've got a few options. So what we'll do first is we'll jump into the actual configuration mode, EIGRP 65001. Now the command to enable stub networking in EIGRP is EIGRP stub. It really is that simple. Got a few options as usual with Cisco commands. We can either just submit that one, and that will basically mean that it will only send up connected and summary subnets up to router 2. We can also kind of make it only do summary, only static, connected, redistributed. You know, I'm pretty sure you can figure that one out for yourselves. And also we've got a receive only here, which basically means it will not advertise any networks up to router 2, it will only receive them. So basically what we'll do first is we'll just go for the standard stub configuration. We can see here that the neighbourship between router 1 and router 2 drops and then comes back up. We can see here now on router 2 we've still got the same routing table, looks exactly the same, but if we go into show IP EIGRP neighbours detail, then we can see here that router 3 is just showing as a normal neighbour. However, router 1, we can see here that it is saying that it's a stub peer and it's advertising connected and summary routes only. So it basically means if there were any static routes, it's not going to advertise them up to router 2. And it also says here suppressing queries, but we'll get to that later. Now, if I was to go onto here, onto router 1 and configure perhaps EIGRP stub receive only, as we mentioned earlier, that means it will not send any networks up to router 2. So once the neighbourships come back up, if we do the show IP route again, you can see here that it hasn't got a route for the loopback address on router 1 because it hasn't been advertised up to it. So anyway, if we go back onto router 1, we'll just take off the stub command for now. I'm just going to enable debugging on here for EIGRP just to quickly show you something. Now what happens usually when a router doesn't have loses connection to the successor and doesn't have a feasible successor is that it will send out a query packet to all its other neighbours to basically say, have you got a connection or a viable route to this subnet? So what we're going to do is we're going to take down one of these links. We're going to take down the link between router 3 and router 2. So we'll go on to router 3 and it's on interface fast Ethernet 0/0. I'll just shut it down. We'll see the neighbourship from router 3 and router 2 drop. It drops straight away on router 3. It could take a few seconds to drop on router 2. We'll just wait for that to happen. There we go, we see that the hold time's expired, so the neighbourship has dropped. If we jump over to router 1 here, we can see, because we enabled the debugging, it's got the processing incoming query packet. The query packet for the 172.16.3 network. It's basically saying, do you have a route to here? Now, obviously we've only got 3 routers on here, so it's not too bad. But if, say, there was another router hanging off router 1 and then another router hanging off there and then another router, and so on and so forth, the query packets would flood throughout all of those, which is going to be a problem because obviously it's going to increase convergence time and, you know, possibly create problems in your network with flooding messages and so on and so forth. And as we can see here, because router 1's kind of a spoke router, there's no way that it's got a route back to router 3, so that's where stub networks come in. I'm just going to turn off debugging now. We'll bring that link back up on router 3. I will just configure we'll just configure on here stub network, just as we saw before, EIGRP stub. Okay, the neighbourship will flap between router 2 and router 1, and we'll see that that's come back up now already. And then we'll see here, so what we'll do is we'll just turn back on that debugging. I turned it off just so that we could, so we didn't get flooded with messages when the neighbourships went up and down. Okay, so we've got the debugging turned back on now. We'll just clear the scroll back so that we can see it. And if we again take this down, instead of this time in theory receiving a query packet, we should just receive an update packet from router 2 saying we no longer have a connection to this. So we'll just wait until, there we go, see the whole time's expired, and on router 1 now, here we go, we can see that it's got an update packet. Basically, we can see here that the metric means it's unreachable. So basically, that's in router 2, when it's received, when it's timed out its connection to 172.16.3, it's, instead of sending out a query packet to its other neighbour, which is router 1, it knows that it's a stub, so it hasn't sent out the query packet, therefore increasing the convergence time and hopefully giving you less of a headache. Okay, any further suggestions for any videos you want me to do, please just drop them in a comment or drop me them in an email at david@davidrothery.co.uk. Thanks very much for watching.